Welcome to the Tall and Urban podcast by the Council on Tall Buildings and Urban Habitat. This is Daniel Safarik. This is Season 1, Timber Rising, sponsored by the USDA Forest Service. We're talking with leading experts about mass timber, a way of building with engineered wood products that is gaining traction around the world. Today we're talking to Jørgen Tycho, Creative Director and Partner at Oslotre, a timber design and construction company in Norway. Jørgen, welcome to the podcast.
Looking forward to it.
Excellent. We know that timber is quite a bit lighter than concrete or steel on a per linear basis. So if that's the case, how does it compare in terms of strength and what are its relative advantages and disadvantages when you're talking about trying to build tall?
Well, first of all, Daniel, it's actually we have been building timber buildings, tall timber buildings for centuries. If we look to the Japanese and Chinese pagodas and temples, you have structures that are 50, 60 meters tall. So, but what we are talking about now is what we call engineered timber, which is when we make the timber into a new product. So these buildings that we are now putting up using engineered timber are relatively new. CLT, cross-laminated timber, was invented only 25 years ago. And we need to also build with it with the knowledge of this being a biologic material. It's a living material, so it is crucial to design with precaution around water and so forth. So it's compared with steel and concrete, it's a living or semi-living material, so it's a kind of a different approach to architecture and construction due to that.
Right, and it's obviously valued very much for its natural aesthetics, and not just in a superficial sense that the market reacts to it because people like it, but also because it has proven biophilic effects.
And this we can see, as you referred to, all this in the work environment and school environments, that people are getting lower stress levels, fewer heartbeats per minute, and less of this, coughing and headaches and all these illnesses you get from artificial environments. So this to use the timber as a passive helper to reduce the need of mechanical ventilation, mechanical moisturing systems. Instead, we use this biological material for this advantage because it's so easily adapting into different climates. And actually, something we're researching a lot now is what you call hygrothermic properties, where you actually use the timber as a passive heating element. So, and then you use moisture moisture and wood to get to heat the air. So actually, we are working with these concepts of natural ventilation and natural heating, only using timber material, moisture, and the sun. So in this way, instead of sealing up the material and only thinking about it as a construction material, we should think of it as a new way of, or at least a modern interpretation of how to use this material to make more advanced buildings, more less dependent on machines and more using more the natural properties we find in the material already from nature.
the production process of engineered timber involves things like glue lamination and industrialized processes that basically make it into a commodity project, a kit of parts that allows for on-site assembly in a fairly easy manner with low labor costs. That's sort of the constructability advantage of it that I've been told. Then at the same time, there are the biophilic advantages, which is like the health advantages that you've been talking about, that rely on being exposed to unsealed timber. Is there a trade-off between the mass production capabilities of engineered timber and the biophilic qualities of timber that we've been discussing?
First of all, I think it's super important when we talk about engineered timber. We need to start to learn to design these buildings with the properties of the timber. Because what's been happening now for the last 20 years on timber is that we are still designing architecture that's based on a steel concrete building system and then trying to adapt the timber into this.
Right, great point.
That will never work. So we need to have a new look at the whole architecture when it comes to timber, because the architecture needs to be adapted to the building or the main building material. And if we do this, we can make buildings with a lot of visual timber and also make slender and efficient and economical structures. But we will never manage to translate the last century's building technique into this building technique. We need to kind of invent a new building technique. But the main issue with not being able to having, or the main reason for not having visual timber is fire. So when we build very tall buildings, we need to be clever about how to not needing to cover up the whole timber structure with plaster, for example, making it uncombustible. So that's for the fire engineers. They need to start to kind of they have to work with how they calculate these fires. So what you should do that you need to calculate the whole complete fire cycle, and then see how much timber can you allow to burn away before the construction collapses. But you have no kind of defined solution. So in every case, you need to actually do that whole parametric calculation case by case, which is it's a bit so the processes are a bit different than what we are used to from steel and concrete.
You know, speaking both as a designer who needs to source timber for his projects and as a former supply chain production manufacturer who seeks a market for those products, should we be setting limits on how far timber needs to travel, in order to be incorporated into a building? Like, at what point do we start losing the carbon sequestration advantage?
Yeah, well, transportation is definitely an issue, and of course we would like more local producers and local suppliers, but also the market is still so small. It's such a young building technique, and for the market to grow, we also need, I think, to accept some higher transportation costs, and both economic and environmental, than maybe in the future will be acceptable, because the market is growing. And I would say that of course the most sustainable is to make something from the local biotope where you but to be able to kind of build the market, we need to allow some spilling of products from other places. And it's a lot of interesting studies around this especially in the tropic areas where you know the timber grows. It has it's sunlight year round, and the plants will grow 3-4 times as fast as in temperate climates. So it's a lot of interesting studies there around locally sourced plants that can be made into engineered timber products. But still at least as far as I know, in the very early research phase.
Extraordinary. Thanks very much.
My pleasure.
Have a great day.
You too.